All right, so we're taking a look at this, Learning Target 2.1, just identifying the solution to a system of equations. Okay, so remember, a system of equations is two or more equations or situations that are together. Okay, so what we're looking for is a solution for all equations or for all situations. Okay, so if we're graphing, a solution is on the line. So a solution to this line right here would be any point on this line. For this one, a solution would be any point on this line. So where they intersect is the one point where there's a solution to both of them. Okay, so that's what we're looking for, is intersection points. Okay, so 2, 3 would be our solution. On this one, 2, -3. On this one, it would be 2, +3, wouldn't it? So we find where they intersect right there. So it's x value of 4, y value of -1, because it's the coordinate. Okay, it's an x and a y value. Number 4 would be -4, 1. Number 5 would be 0, 3. And number 6 would be right here at 1, 1. Okay? So again, that's all there is to it when you're dealing with a system of equations, is trying to figure out those pieces. Okay. Now, if you were just given the equation, it would be a little bit more difficult, wouldn't it, to figure out. So your best bet is really to graph it and find what that point would be. However, there are other ways that you could do it. You could solve it algebraically and find where they intersect as well. Okay. In this case, I could take these two. I could subtract 2x and get y equals 10 minus 2x, which then I could substitute for the y value in my second equation to get just the x values together. And I could solve that, distribute, so 3x minus 50 plus 10x would equal 15. Add 50 to both sides. We get 65 equals 3x and 10x would give us 13x. Okay, then divide by 13. We'd get x equals 5. Then we'd take that x equals 5 and plug it into our other equation to find what y would equal. So 2 times 5 would equal 10. 10 minus 10 is 0. So at the point 5, 0, that's where that would be the solution to those two equations. Okay, you could also do it using elimination as well. Okay, a different method. Say we had 2x minus y again equals 8, and then say we had -2x plus 4y equals 12. Elimination, you would find variables that have the same coefficient. You'd add or subtract to get rid of one of them. Actually, let's change this to 13, because then that would make this one work out better. Okay, so we get y equals 7. Once we know that y equals 7, we'd have 2x minus 7 equals 8. Add 7. 2x equals 15. Divide by 2. And x would equal 7.5. So the point would be 7.57. Again, you can graph these as well and find their solutions. And that's what we're concerned about, is the fact that that solution is the point where they intersect. Okay?